Hi, everyone. Welcome to our broadcast, Mastering Advanced Machine Tool Setups with the CNC Digital Twin. Have you ever found yourself thinking, are these complex machining setups slowing us down? If so, then you're in the right place, because there really is a smarter way, and we're excited to share some strategies with you. My name is John Meyer. I'm the Marketing Communications Manager for the Siemens Machine Tool business, and today I'll be your host and moderator. Before we get started, I'd like to cover just a couple, 2-3 general topics. First, today's webinar is being recorded. After the broadcast, everyone will receive a link to the recording so you can go back in case you miss any part of the conversation. Second, to prevent any interruptions, all microphones have been muted. And third, should you have a question about the content being presented, please use the question field in the upper right-hand corner of your screen. We'll have a Q&A session towards the end of the broadcast. By the way, also in the upper right-hand corner, you'll notice the Handouts tab, where you'll find a white paper we published recently. It's a great resource, and I highly encourage you to grab it before the end of the broadcast. You'll also see an overview of the Siemens Technical Application Center, which we'll talk about momentarily. Today, we're going to dive into how Siemens CNC Digital Twin technology is revolutionizing advanced setups, specifically through the incredible work at TRAK Machine Tools. I'm especially thrilled to have my colleague Chris Pollock and Les Tolnai from TRAK Machine Tools, who will share his real-world experiences. During the discussion, you'll hear how TRAK leverages shop floor programming and the CNC Digital Twin to achieve unparalleled precision and efficiency in their manufacturing of CNC machines through approaches like in-process probing and measure-cut-measure. Just think of the impact: significant time savings, reduced costs, and minimized waste, all while boosting your efficiency. So let's go ahead and get started. Chris, take it away.
Thank you, John. Appreciate the introduction and looking forward to getting a chance to spend a little time with everybody here. Of course, I got the mic now, so I'm gonna be a little selfish and give you guys a little bit of housekeeping from the Technology Application Center side. So for those of you that may not be familiar with me, I manage our Technical Application Center, and I have the pleasure of managing three awesome contributors and stellar guys. Dan Struble, he's a CNC specialist for me. I have Adam Caves as one of my technology systems engineers, as well as Brian Baumgartner. So these guys are out there kind of driving all things Cinamerica into the market space. So if you don't know us, you want to get to know us, because there's a ton of things that we can help support you on. And to kind of show that, and speaking to what John had mentioned, there are a couple slides here that just kind of support all of the resources we have available online and through our team. So one of the big things our team does do is we host training classes. These are hosted monthly. Sometimes we have multiple classes a month. And there you can learn all things operation and programming, service, commissioning topics. So if you're interested in Cinamerica and you want to learn more, I would absolutely check out this link. And like I said, when you download the slides, you'll have all the hyperlinks there for you. If you're not familiar with our Mr. CNC YouTube channel, you should get familiar with it. There's a ton of information all around the operation and programming topic. I think to date we have 180 videos or something crazy on it. So check out, make sure you like and subscribe, right? We also have a virtual product expert program, and this is a great way where you can book time with a subject matter expert, whether it be myself or one of my team members, or really just about anybody we can leverage within the Siemens organization, and dig into a topic that you're interested in, specifically tailored to your needs. So check this out. You put a little request in through the CNC for You website, right? Or CNC for You, and you can put in a request to have a VPE. We also have our content manager, great way to navigate all of the material that we produce. This is updated on an annual basis, so you want to pull that down every now and then. It's got hyperlinks to all of our video content. We have our contact list. Make sure if you're not on it, you want to get on it so you'll get emails and notifications when we have more material out. And we also have direct links to our different YouTube channels. And with that, we are excited to announce we have relatively recently stood up a new YouTube channel, a sister channel to Mr. CNC, which is the Mr. CNC Insights. And this channel is focusing on more service and commissioning topics. So maybe you're using our product more from the support side. Check out this channel. Good chance it's going to have some great information that supports you. But without further ado, I would like to bring Les Tolnai into the conversation and say hello, Les, and thank you for joining me today. I'm excited to talk to you.
Thank you, Chris. Pleasure to be here.
Great. So Les comes with a vast amount of knowledge. You can see right there in his quick little bio. Been working in this industry for over 50 years, starting to date himself like myself as well. But, you know, certainly I think there's a lot that we're looking to get a chance to learn from you today, Les. Really excited to dig into not only TRAK and what TRAK's all about, but more importantly, what you've been doing in some of these, new methodized parts. So not to give it too much of a teaser, we'll start to dig into it. But what I did want to start with in the beginning is, we may not have a lot of people in the event that are too familiar with TRAK. Especially this is being presented globally. So we have a lot of attendees that are going to be coming in from, other parts of the world. So in your mind, what would you say TRAK is best known for in the industry currently?
TRAK has a long history of trying to make innovative, user-friendly products to help people through their projects and programs and give them the best approaches that we can.
Perfect. And with that being said, what kind of machine tools does TRAK currently use in the machine shop? I know from your bio, you're managing the machine shop. So what do you kind of got there? What do you get to play with every day?
Well, we've got a combination of lathes and mills, surface grinders, horizontal mills. Most of our product has really shifted over to Siemens controls. We do have our own controls, ProtoTRAK controls, that we do use on other equipment that we have, lathes and mills. They're more for shorter runs and quick conversational programming. And a few of the pieces are Mazak machines that we have in here, horizontal mills and lathes, that kind of thing. So we've been across most of the milling and turning spectrum. We're trying all kinds of different faucets, whether it's a 3-axis or with a 4th axis, or with a trunnion, a 5-axis machine. So we're approaching all kinds of different aspects of the equipment and trying to find the best combinations, the best scenarios, and again, something that we can help our clients with.
And I would assume this kind of speaks to, Steve Pinto, the president and owner. He talks about like this whole retooling project of the machine shop. What's the big goal there, in trying to revamp your shop? Is it just throughput, or are you trying to kind of explore something more?
Yes, and yes. Throughput is always a good thing because we are the production machine shop for TRAK. We make a lot of the parts that we use in our equipment, but we are always looking for better ways to do things. Technology has moved along quite a bit and keeps evolving and changing, and we try to keep abreast of it instead of playing catch up with it. So when we do that, we garner knowledge, gain benefits from it, and we can furnish that information to our customers and give them solutions for their parts or their problems.
Very cool. I mean, definitely positions you guys in a great spot where you can help educate the customer, right? Instead of just worrying about selling them a piece of iron, you can really kind of become almost a trusted provider to that customer and really help him grow with technology. It sounds like the way you guys are growing with technology as well.
Well, that's what we try to do. And it's like I said, we're using a lot of our own equipment that we market. So we are trying to practice what we preach. We're not trying to sell them something and then we're using some other equipment to make our parts. Let me show you how we can do it, what we've been doing with it. How does this apply to you? We try to give them as much help as we can with this. Our machine shop is not only a machine shop and a production area, it's also a showroom, a demonstration area. When clients come in, we can show them, oh, you're thinking of this mill or this lathe. Well, here's what we're doing with it. Here's how you could use it. Here's how you can gain from it.
Very cool. So you had mentioned you're switching a lot of machines over to the Cinemark Control, the Siemens Cinemark Control. Was this your first time or chance to really experience our control platform?
No, I have used the Siemens control, but it was many years ago. It was an older generation control. Don't ask me to recall the model number at this time. It has been a long time ago. I've been using the Cinemark One now for about 4 years. Okay, and first started it with the mills. For the lathe, then moved on to the mills, and then 4th axis and trunnion 5-axis. So I've been learning and moving along with it. There's many things that I love about this machine, and one of the main things that I like is that it's shop floor programming, conversational programming, very similar to our TRAK models, because we have parts that we make and everybody has them, and then you've got a part, and then Rev B comes along. You can quickly update it right there on the floor, capture it, go, okay, now we're good to go, and keep moving on. Instead of pulling it off, going off to programming, redoing, you can adjust right there on the fly. So it's very simple for the operator. Once they get acclimated with it, it's event-based, just like our ProtoTrack. So the Siemens is the same kind of thing, event-based situations. You put in some information and it does a whole bunch of work on its own.
Nice. Yeah, I definitely will have to say, working hand in hand with you guys on the adoption of our product, it was amazing to me how easy it was to train your guys because of that similarity and that commonality between the products. For sure. So to give the audience a little bit, what kind of technology do you have currently to date in the shop today?
Well, like I mentioned, we have lathes and mills. For the lathes, we have standard 2-axis lathes. We have live tooling lathe.
Okay.
We have second spindle lathe, bar feeders, robotics that we use for some of the machines, different kinds of robot systems we were trying and using and developing different products with. For the mill side, we have the 3-axis mills. We have with a 4th axis. We have with the trunnion. We have large envelope machines, VMC 14, which is our biggest vertical machine. We have the horizontal Mazak that I had mentioned. And we have small machines with our own control, with a ProtoTrack control, what we call VMC 2s, which are a little small, pallet jackable, movable, readily placeable secondary support or mini machining centers. So we kind of cover all kinds of aspects, and we're trying to grow them all into the newer technologies and advance it as much as we can, like I said, so we can give the customer the biggest bang for their buck.
Very cool. Well, with that, I want to dig into today's application because it is a pretty cool one. And we like to refer to this as the challenge. So from what I understand, you wanted to kind of remethodize how you were currently making the main housing to your turret body, to your eight position bidirectional turret. So why don't you give us a little bit of background of how you traditionally machined it prior to us talking about how you went about the new process?
Okay. Well, this is a cast iron part, casting, that had multiple setups and operations that we did to get the part up onto fixturing on a 4th axis so I could spin around and catch all the 4 sides. We did the bottom that it's sitting on, we did the top, and then we mounted it up on a 4th axis, went round and round. But this part, we had quite a bit of setup time with it, with all the separate operations, down 4th axis nicely, the tool capacity of the machine. This was all done on a Mazak, okay, with a 4th axis. We had quite a bit of problem with maintaining some of the dimensional integrities that the part requires. And that's kind of what changed our approach to see how we can better automate it with less operator intervention.
Okay, and then I think that answers my next question quite well. What was the driving force between remethodization? What kind of design considerations kind of went into when you were developing this new process for the turret housing?
Well, because it is a turret housing for a tool indexer, it's got some critical areas in there that need to be maintained so that the product performs correctly. On the part itself, inside the housing, there are two bores that are plus or minus 3/10 tolerance bores, need concentricity to each other within 5/10. And then the two bores centerline, where the turret indexing shaft goes into those bearing bores, has to be maintained to the base of the housing, parallel within 1. So those are the main considerations that need to be addressed and curtailed. So by using the trunnion, I was able to probe the bores to sustain the sizes, and to probe from the far side to follow the center line, regardless of if it shifted a little bit in the fixture or whatnot from first op to second op, to retain the two bearing bores in line and concentric, and again, keep their sizes within the 3/10 tolerance. So this was all done, and it's all being handled by the machine automatically. Basically, the operator is just kind of double checking the bore sizes with a bore gauge just for a sand check. But the system is measuring, updating, and actually capturing the data in a document where we can match it up to the serial number of the part, so we have exact readings as to what the machine found and did.
Very cool. And with that being said, we have a nice little video that you guys produced that kind of gives us a really good overview of what we're going to be digging into a little bit more as we progress in today's session. So certainly from my side, I'm seeing the digital twin. Definitely going to have a lot of questions around that topic for you. Looks like you're doing a little boring processing. Up here we go. I see the new 5-axis. Very cool. So we can certainly dig into that technology. Oh, there's your measuring process, like you were talking about, going in and qualifying those bores, doing a little multi-sided machining. Up now you're getting in and doing the check. Very cool. A nice looking part. Looks like it was certainly a fun part to kind of methodize on a 5-axis trunnion, as you guys have done it. So with that being said, I think why don't we kind of dig in a little bit now that the audience gets got a chance to see what this whole thing's about, and we can maybe talk about the digital twin first, because certainly from my side, it's definitely a product that we offer that excites me and excites a lot of our customers. I'd like to talk a little bit about your perspective on it. Looks like you've done quite a bit with it. First, had you ever used any form of digital twin technology prior to Run My Virtual Machine and the Cinemerc product?
No, I had not. And one of the prerequisites when I was asked to put this part up onto the trunnion is to get the digital twin working for me so I can put everything in there, because I go in there with some very long, expensive tools, a very expensive probe that needs to reach down inside of a cavity. I would rather see everything up there on the PC. If it makes an error or crashes on the PC, I can forgive myself and just go fix it. I can see the projections of my tools and my holders and any interference on the PC, where I go, okay, well, that didn't work. Let's go back to the drawing board before I get out to the machine. So it gives me a lot of confidence when I get out to the machine that this is going to work. I'm not going to have some really silly something come up, hold up the machine, go back to programming, waiting to come back. I can pretty much make a very good setup and program, go out there, basically maybe a little minor tweakage here or there, and I'm safe, and it's consistent, and it runs. So it's very handy, very, very much a requirement when you're trying to get into deep cavity work and you've got a lot of tools and projections.
And did you say that you had not used Run My Virtual Machine prior to the 5-axis machine? So like the 2-axis lathes and the 3-axis mills you first adopted?
No, I have not, because generally speaking, a lot of the parts, I was able to just use the verification process in the programming side without the machine itself, and seen enough as to, because the parts were not that sophisticated or complicated and cumbersome to reach into. So I was content with those kind of verification methods. But this one, it's like you can see the part, There's a lot of detail on there, and I want to make sure I'm getting them and getting them in the right order and watching my tools and my lengths. You can see some of those holders are quite long and projected. It reaches inside the part, it reaches to the first area, and then it goes on down further and further. I don't want the flange touching, nothing. And this gave me that overview.
Now, you had mentioned the other parts in the past, you were programming actually through shop mill or shop turn or shop floor programming tool utility. Did you do the same technique here, but just leveraged it through the digital twin?
Yes, pretty much. One of the differences was when I was doing this part, this was the first time I was using a trunnion. So I had to learn to understand how the software was handling things. So this Run My Virtual Machine gave me that chance to get acclimated to the 5-axis software and what it does when I do this or I do that. Again, not out of the machine, tying up the machine, and any errors or went the wrong way or something or other, I was able to capture it on the PC and readily correct it.
Very cool.
So it's very helpful for these kind of things. It's anytime you can do that on a PC, you're not tying up a machine, you're not crashing a machine, is all in the plus column for me.
Yep. And you can keep that machine spindle running doing something else while you're doing all this. You're not standing there with the machine sitting idle. So with that, did you guys see any cost savings by leveraging the digital twin outside of what maybe we've already stated?
Machining time was pretty much machining time. I didn't really see a big difference in there. Where we saved a bunch of time was the setup and the inspection, and of course the reduction of scrap. Okay, because it maintains itself. It's like I said, the operator's basically just sanity double checking the bore, looking at the heights, but everything just keeps coming out by the numbers from the machine. So we save a lot of operator nervousness and intervention time where the machine's just running. The operator is free to do other activities, which is the costs are being saved by going somewhere else with his time.
Yeah, absolutely. Now, do you feel the digital twin helps in reducing the learning curve as well?
Yes. Because, like I said, you can play with it at your leisure. Let's say somebody new, like I was new to the trunnion aspect of this. I had to figure out how that's actually working and updating and incorporate the moves and the clearances. And it's a good training aid, and it can be done offline. You're not tying up an expensive piece of equipment. You're not risking the factor of crashing an expensive piece of equipment or tooling. It's an offline learning vehicle, and even if you're not doing something very sophisticated where you need it, it's a good training mechanism. But if you're doing something sophisticated, it's definitely a plus.
Nice. Very nice. So from that, obviously you guys transitioned to 5-axis. So am I assuming that this was your first 5-axis in the shop, or had you had 5-axis before?
This was our first 5-axis in the shop, and this is what we're trying to leverage with other parts similar to this, similar multi-sided parts where we can reduce the setup time, we can reduce the operator's intervention. We're trying to leverage that further and further with the right parts that apply. So we're trying to pick and choose our battles right now for the most demanding parts.
And can I safely say that it looks like you took however many operations this part was and probably got it down to 2? I would assume you're probably prepping the bottom, finishing up that, and then once that's mounted on the table, you can handle everything else in that clamping. Is that correct?
Well, we do have to machine what's kind of facing that side of the part, the top face. I do have to machine that first. Also, I do the bottom mounting base, and I clean cut the top face because I need to grind the bottom face for a good flat surface so I can maintain all my bores and everything. So I still have to at least do the top face, but I don't do all the details. I do the details in the trunnion. I just need a good surface.
Got it. That makes sense for sure. So in moving into 5-axis, what would you say the one biggest challenge was? Maybe that you especially didn't anticipate?
what I didn't anticipate.
I stumped you.
Yeah, you did, kind of, because I knew I was getting into the deep end of the pool with this part first thing out of the gate using the trunnion. So that was kind of it. I had to build up the tool library, and I kept changing out some of the holders in order to get my projections in there. Because, oh, I got one, and then I'm going to have a problem. So that took a little bit of time. But by going through a part like this, I do have some tools and holders in my library for the Run My Virtual Machine that I can leverage on other parts, and I have a better idea what to watch out for, so I don't have to program it 2-3 times to be satisfactory.
And by leveraging 5-axis, how would you say it's impacted overall your setup time? You know, there's always that fear. A lot of customers are worried that the setup time is going to be significantly more because of the complexity. Did you find that?
No. The only thing with the setup time that is considerable is because you can hit all sides of the part. Depending on the part's configuration, you've got a lot of tools that you need to put in, because you can machine every aspect, every tap and drill and size that you need, all the different end mills and whatnot. So it's the amount of tools that you need to capture and load, that all at once. But other than that, for the setup, the alignment, the system is very simple. Basically, I program the center of the table, and I park the part centered on the table and update everything from there. Everything transitions and rotates. The system keeps track of where that bore went from 0 degrees to 90 degrees to 180 degrees, and my moves move with it. So it keeps everything in tune with itself, by itself. So it's just, how do you make your setup? Where's your 0? And keep that in mind as you start rotating the part for what you're programming, because the machine knows where it went. So it's all built in there beautifully. And then, like I said, when you sit there and you've got tight tolerance bores center to center, the machine is not updating a lot to shift from one bore side to the opposite bore side, because I probe the through hole that is done on the first side, and it moves a little, 5/10, 7/10, little compensation for the second side. It's just maintaining. It's just following that by ever slight increments. So that leaves me with a great bit of confidence to just let the sucker run.
And you know what? That says a lot for the precision of your machine too, because no matter how good our control is, if your machine can't position that well, it's not going to hold it.
That's true. That's true. And that's why I'm not trying to take anything for granted. I've got double check redundancies in there because it's like, it's tight. It's tight. So you got to be careful.
So from, the early stage of how you were historically producing this part to now, how did it impact the manufacturing time? Would you say it's the same, just, better quality, or did we actually reduce cycle time?
There's probably a little reduction in cycle time, but not so much, because of the cut times that are required to create the part and all the different tools that are all combined into one. The setup time is slightly reduced because we don't have to dial in one fixture to the other fixture to the other fixture so much, because the 5-axis software, the transformation is handled by the computer in the control. So the runtime, like I said, is maybe a little bit better. The quality has gone through the roof. I scrapped the first one when I was making it, but after that, we ran 20 parts, no problem. We ran another 20 parts, no problem. We didn't lose anything, okay?
Nice.
So the quality is there, and it repeats. And like I said, it runs so well, once the operator lets it go, he goes and does something else. It could be on the other side of the floor. It doesn't matter. It's safe. The machine is handling itself. So we freed up the operator, and that gives us savings.
All right. So the third thing I definitely wanted to dig into, and probably one of the areas that I love playing with and leveraging myself whenever I can, is in-process probing, the whole measure, cut, measure strategy. So I have to ask, first scenario, were you new to this on-machine probing technique, or had you been doing that historically on other machines?
I have done it on the Mazak horizontal that we have. We have probing up there and updating the tools, cut, measure, cut. So I have used it there. I have used the Siemens probing before for aligning or picking up parts or whatnot, but not so much the measure, cut, measure as we did with this part. So that was a little bit new to do more of in a production environment.
Got it. And when you say you were using the Siemens probing, I would assume that would have been on the 3 and 4 axis technology. Some of the other machines had prior to
aligning apart, leveling out a casting, whatever. Yeah.
So I know we've kind of talked about it a little bit, but the real driving reason for adopting this technique, if there was just one thing that you would say that would really kind of drive a user that's maybe watching the event to start to consider adopting kind of an in-process probing and a measure, cut, measure, what would you say that one driver is?
Being able to automate and maintain your quality and free up your operator without having to intervene consistently. The machine can handle it on its own, and you can trust what it's doing. That's the driving force. So if you've got something that's tight and critical and you need to maintain, you can do that. If it's wide open tolerances, you don't need to worry about it so much, but you could document your facts as to what you're getting out of the part for your inspection, for your quality department, etc. But on critical parts, it just frees everybody up, and the confidence factor is strong.
Now, have you played around with it on some of the other machines yet, or are you looking to try to implement this maybe to some of the 3 and 4 axis applications?
I have used it on some of the 3-axis applications, not the 4th axis really. I have other parts that I am currently working on that will go across the trunnion that have similar kind of features. I'm trying to find parts that are more problematic, more operator intervention required kind of circumstances. Those are at the top of my list to do first. And then we'll see what new products we come out with and what the driving forces are as to where we go with it.
Now, I'm curious, you mentioned you guys have been integrating robots as well into the manufacturing line. I know from my own experience, that's an area where we tend to see some inconsistency on part loading. Have you played around with it just to take out any of that deviation to where the system will kind of self-adjust to the fact that the stock was maybe dropped in a little shifted, in whatever direction it would be shifted in from the robot dropping it in? Have you played around with it from that side?
Yes, I have. We're using a couple of different scenarios, and when we do it on the lathe, we use some of the robotics. We're using a UR robot. There's actually a spring-loaded push plate that double checks when you put the part in with the robot. The robot puts it in a little shy. I don't use pressure from the robot. I set it in a little bit shallow. Come in with a spring-loaded plate in the turret, mounted into the turret, pushes on the part, opens and closes the chuck, so I get a repeatable Z-axis result. As far as the parts that we're doing, a lot of them have plus or minus 2/3 bores and concentricities on opposing ends. We are rough machining one end. When it puts the part in the opposite end, we finish the front bore and then we back bore at the same time. So concentricity is built in. Sizes are controlled. The program is done so that it runs a little bit slower, but very consistently, and same with tool life. So you build in a lot of the factors. Yes, there is extra work to be done with it, but if these are the points that you watch out for, yes, they can be contained.
Very cool. And that's a neat technique. I never thought about doing that spring loading technique to make sure you finally seat the part. I'm going to put that in my my memory banks. I'll probably be stealing that from you one of these days for sure.
We've been using it on the lathe, but we haven't used it on the mill. We haven't found the need. We haven't got the part where we need to do it as of yet, but it's applicable there also.
And you have gravity in your
that also helps, but yeah.
Yeah, absolutely. Well, very cool. This was awesome. I was really excited to be able to kind of dig into some of your stuff. I'm sure the audience has a lot of questions for us as well. So why don't we kind of transition over? Let's bring John back in and let's see what kind of audience questions we have.
Yeah, guys, we do have several questions that have come in. So really quickly to the audience, please keep the questions coming. Feel free to use the audience chat. Some of you have been doing that. Otherwise, please post them in the question tab at the top. So let's start here. From the moment you import the CAD geometry into the software and to the moment the G-code is exported, how long does that process take?
Well, like I said, this was my first part, and I was learning the 5-axis software and everything. And because of the deep cavity reaches and whatnot, I spent a good week on this, building tools, building the program and everything. And the export, like I said, I did this in Shopmill. I did not create a G-code program. So this was purely Shopmill programming.
Conversational programming.
Conversational, yes. And that offered me that option out there on the machine to do real quick little tune-ups to the feed's a little high, the step over's a little big, stuff that you can't really feel so much on the PC. You can shake it out there on the machine.
Now, I certainly got a question to build off of that. We do have a feature for DXF importation. Have you played with that at all, Les?
Very little. Basically, what I did was I imported the model into Run My Virtual Machine, brought in step files and built the tool holders and everything up in there. And then I programmed, like I said, in Shopmill, because I wanted to see the Shopmill program out there. And I knew which features I wanted to do what with. The DXF, I didn't really use. I've used it before on other parts, but not in this case.
Yeah, I guess, I mean, if you don't have the geometry that really requires it, it's probably not that needed, but certainly for regular contours and stuff, even to be driving them in Shopmill, to have that kind of freedom of bringing in a drawing file and keep you from having to plug in all those geometrical points, certainly can save some time. Very cool.
All right, the next question looks like this might be a two-parter. What is the measurement error on the geometry of the digital stock material cut with a probe? And how do you handle this measurement error?
What is the measurement error? I'm
Geometry.
wondering if they're referring to the deviation when probing in the digital twin.
Well, then there's a sub-question to that. If I have a tolerance check cycle in the measure, cut, measure process, and the tolerance is 0.001, so 1/1000th of an inch, how can I handle this in my digital twin?
So what I will say is there is always going to be some form of discrepancy when you're starting to measure in a digital twin. And a lot of people don't realize it, right? You would expect, the expectation would be, I'm going to measure something in this digital environment. It's going to be perfect, right? What we don't think about is nothing's ever round in a PC. In fact, what it is it's a bunch of little flat facets that kind of look like something round. So depending on the quality of the model and how large those facets were, when you start to probe, you can hit anomalies in the digital twin that you won't see in the real. Because in the real, we can cut something that is effectively round instead of having to deal with all these facets. So you deal with facets on the ball of the probe stylus. You deal with facets on any time you have any kind of a curved surface. So what I would say from that is you're always going to tweak your final tolerances and your process once you get down to the real, because that's where everything's going to be perfect. But I actually use the error, because there is more error in the digital twin because of these facets than I'll experience in the real. I use that to my benefit, because if everything was perfect, I can never trigger the check of me being out of tolerance. So now I can play with those bands to actually force an out of tolerance spec. So hopefully that answered their question. But yeah, you're always going to have that play. So you'll have to tweak the tolerancing once you get on the floor to really get it sized in.
Sure.
Precisely, Chris. You addressed it exactly as I had discovered it up there too. Precisely.
All right. Another question revolves around the ease of implementation. For machine shops considering adopting similar automation, what are the key factors that make the TRAK machine system particularly easy to implement compared to other advanced machining solutions?
Okay, now there's a TRAK machine and there's a TRAK machine. We have TRAK machines that use our ProtoTrack control, which are user events, conversational programming, very much the same as Siemens. They are a different platform. They have different ways of asking the same questions, but it's event driven, very much like the shop mill. So both of those work very well on the shop floor, but by running them, both versions have offline versions that you can run on your PC. Again, I would highly recommend for somebody getting to either one of the platforms coming in new is to use the PC as a learning tool instead of tying up the machine to practice and learn. Both of them are very easy to use once you find your footing. It's just like every time Windows changes to another rev, you know exactly what you want to do, but you got to go find the button.
Now let me jump in and answer that from the perspective of a customer for a second. So a lot of people don't realize, but in our training center, we have multiple machine tools. And one of the machines we have is a TRAK VMC7 SI, obviously with a Cinnabar control. And it's a full 4-axis setup. Now, what I would say in the adoption of TRAK's technology, or what maybe makes it a little easier than some of the other competitors in the market space, specifically, I think the way you guys option the machines is great. When you get that machine and you get that initial quote and that price, this is not a machine that has been watered down and nickeled and dimed down to where, okay, now I have to have 30 conversations because, oh, you wanted a flood pump with that? Oh, you wanted weight coverage with that? This machine, all of them across the board, I've always been really kind of super impressed how well you configure the machines at the base price level. So to give you guys an idea, so we got our machine, we got the initial quote, we looked at the base price, and then I look and I say, wait, that's coming with a 12K spindle. It's coming with an arm style 30 position tool changer. It's coming with a high pressure 300 PSI through spindle coolant, and it came with a chip conveyor, all for the base price. So you talk about making it easy to adopt this technology. You don't get in the weeds. They're giving you what you need right out the door. And really, the only thing I think we added was the 4th-axis table, and then away we went. So if you're considering the TRAK, make sure you do an apples to apples comparison, because if you really put these things up pound for pound against the competition, good luck, man. I mean, they make a hell of a machine, and the price point is almost unbeatable, I think.
There you go. The next question revolves around measure, cut, measure, and it's perfect to, what we just talked about. So what all is involved in getting this to work on the machine?
It's adding an event with the probing cycle. You can go in and have the probe literally just measure a feature, or you can go in and have the probe measure a feature within a tolerance limit that you set for high, low, or whatever, and have it compensate for that tool, for a tool, which is actually the tool that is finishing or machining that dimension. So it can automatically update that tool's cutter compensation or depth, whatever you're measuring. It can automatically update that offset so that you don't have to intervene.
And I would say, building off of that, a lot of it will depend on how far you want to go. But what we'll do quite commonly with measure, cut, measure is not only will we intentionally drop in a bore and make sure we adjust the tool geometry based on the current dimensions, but you can actually start to incorporate some logic commands as well to say, now I want to double check and say, was that measurement within my spec? And if it was not within my spec, let me not only adjust the tool, but let me continue to remachine the feature until it is in the spec. So, I mean, you can go pretty far with this thing. I would say on the basics, most guys will go in, drop into a finished feature, make a quick check. As long as it doesn't flag that it's out of tolerance, just update the tool so it'll be even more accurate the next time. But you can start to leverage our advanced technology commands. And to plug the beginning, our level 4 class, we teach you how to do all that stuff completely free of charge. So check it out. But yeah, you can do some pretty trick stuff. But you will start to get into a little bit more logic-based programming. So what you would do there, like even less the way you developed yours, you can insert G-code lines in the middle of that conversational program to start to handle some of these higher level language style commands.
Mhm. Yeah, I'm aware. I was just able to sustain myself. It's 3/10, but I was able to keep it and just updated a tenth here, updated a tenth there. Move on.
There you go.
Okay. How accurate is Run My Virtual Machine runtimes versus the actual runtimes at the real machine?
Surprisingly, very, very good. I've seen so many estimators that were out of line. Your best guess was as good as that, but this is very concise. I've seen very accurate times on a lot of programs that I've written through the years. It's very impressive.
Yeah, and I would say the one thing from our side that attributes to that is the digital twin is being built taking into account all of the optimized machine parameters that you guys at TRAK have done to these machines. So we know it. I would say the one area where you'll see a little discrepancy is just tool change time. Most OEMs don't go fully through trying to automate the whole tool changer because there's not a lot of value there. So what could I have as a discrepancy? Maybe in the real, it took 3 seconds to change the tool, but we estimated it as a second in the digital twin. But outside of that, yeah, it's effectively going to be a 1-to-1.
Yeah, and I think that the biggest attribute to that, Chris and Les, would be that, with Siemens, the NC kernel of the CNC is built into the digital twin. So that's what makes it so realistic. 1-to-1.
As I like to say, the brain of the CNC is in your PC, for sure.
Another question. How difficult was it to get models for tooling and work holding?
It was not difficult. Tooling, as far as the cutting tools themselves, are readily available from many sources. I'm going to plug Kennametal in here for one. They have a very good array of tools, free downloads, vast amount of choices. You can change your lengths, your diameters, blah, blah. Tool holders, again, Kennametal is another good source for them. But there are a lot of companies out there that offer models and downloads. You just need to cruise the net and find the ones that apply to you. They're not difficult to find. You need to bring them down, move them in a step file. Run My Virtual Machine wants to see them in a step format, and then you can use them. You mount your tool in for whatever projection you want to tell it to have from that holder. The holder's length is already built in, and you go to town.
Yeah, agreed. It's not hard to find these models. I work with Kurt all the time from their work holding. You go to the Kurt website, you can download, I think, just about every vise they have, pull it down as a step file. Same thing with tool holders. As Les mentioned, Kennametal's great for that. I've pulled holders down from Sandvik and all the top producers. I would say if you deal with a lot of like boutique-y kind of builders, in the most smaller mom and pop shops, that gets a little trickier, but at the end of the day, usually that's cutting tools, like round tools, and you don't need a full 3D model of that. You just use the parametric one that the system builds. It's really the holder that we want to have some decent fidelity so we can know if there's going to be any collision potential, like, less dropping down into some huge hole.
Precisely.
The next question is regarding the actual probe. Is there a Siemens probing software for Renishaw RB600 available?
So all of the probing is using our standard cycles, and they are supporting really any manufacturer's part probe out there. So you can use it with the Renishaw versus Marpos or Heidenhain or anybody's probing routines. So I'm thinking that's probably what they were referring to. Now, in addition to that, we do have customers that like to use like Renishaw's what do they call it? The measure plus or something along those lines, where it's using Renishaw cycles. All of those can be commissioned on our machine. But I'll be honest, the bulk of our users are using our standard integrated cycles just because they're conversational, they're easy to use, and they've really been designed around that one control platform. So it just makes them seamless.
There's still a few more questions here, keeping an eye on the time. The next question, before the measurements, which way do you recommend for RTCP collaborations in Create My Virtual Machine? An RTCP 4 to 5 axis transformations parameter.
So I can only assume they're talking about tool center point control. Now, in a machine like this, in this application, although the machine has tool center point control through what we call Traori, Les isn't using any of that on this part. This is a traditional 3+2 part. So what it is using is it's using our swivel cycle, which is also known as Cycle 800. And that is what manages your dynamic fixture offset. So as Les mentioned, he didn't have to think about where this thing was swinging to. The control knew. It knew because there's really two cycles that'll do that. Cycle 800 or swivel cycle, that's your 3+2, or full dynamic TCP with Traori. But in this case, doesn't matter either one. Now, for a system where you are going to run Traori or TCP, you can fully realize that in my virtual machine. The systems are already set up with a specific, point of rotation. So as you simulate, it's going to track off that point of rotation. You really commission tool center point control in the digital twin the same way you would commission it in the real.
Okay. Let me keep checking the panel here. While I do that, let me just push out a quick poll to the audience. All right, the next question, it's a little bit longer one, so here we go. When testing out your program in the simulation environment, how can you be sure that there won't be any real collisions? On the real machines, sometimes I need to use different fixtures to secure my part, and sometimes I also need to use special tool holders. Can these be modeled within my virtual machine?
Absolutely.
So, yeah.
And that's what I did with them. And that's why I said, when I ran this part and run my virtual machine and I seen some of the tool holders are going to touch down, I need a different holder. I need a longer end mill so it doesn't shank out on the bottom of the holder. Run my virtual machine, captured it, and flagged me with a big red screen right off the bat. So I knew I had to change something.
Yeah, and basically it's this. If you can provide me a step or an STL, I can import it into the software. So yeah, maybe the vise you're using or the work holding you're using, you built in-house and it's totally custom. Okay, just model it up in CAD, which I'm sure you probably already did because you designed it in the first place. Export it as a step or an STL and bring it in. Same thing with holders. Very commonly I may go in and just, modify a very simple holder because, I don't really need to go through the full fidelity of having the 40 taper of the cat holder that's inside of my spindle. It doesn't mean anything to me, but I want to know what's happening at the tooltip. You can either create those with primitives right from within the software or just import them as a step or STL.
All right. Does my virtual machine include any measuring functions within it? What if I want to check my part geometry or tooling geometry after I've already imported it?
So yeah, our current version of my virtual machine now has a measuring function. So where I can start to measure my 3D models, I can measure not only the fixtures or the holders that I brought in, but you can also measure the stock model and the in-process workpiece model during your process too. So if you wanted to just do a double check to be like, hey, did I really cut that board to some dimension? I don't have to go digging through the program to find that event where I programmed it. I can literally measure the in-process workpiece.
Has anyone experience with probing castings and realigning the finished geometry to the casting location on horizontal machines?
Yes, we do with the Mazak horizontal. We do castings. The first operation is put up there in an eyeball kind of situation location because it hangs beyond the vise and I need to machine the ends. It's in there roughly. So the program comes in and literally probes the center of the bore and aligns, fine adjusts the fixture offset for that machining operation. Siemens can and does the same thing. I have used it on a couple of castings on 3-axis machines. I've got fixturing that locates off the outside of the part and aligns everything, but the main feature and what truly need to be followed is the cast bore. So then I come in with a probing routine and align the fixture offset to the casting, regardless of where the fixture, the outside size of the casting is. So yes, you can readily update.
Okay. Another question was actually similar to what we already talked about. How accurate is the program runtime in the simulation software? We said very, very accurate.
Very good.
Pretty much 1-to-1. Les, this is a question specifically to you. Would you feel comfortable training a newbie to program and set up the machine using Run My Virtual Machine? If so, what is it about the product that makes you confident in that process? And specifically, they're referencing G54, G55, etc., fixture offsets.
Yes, I would be very comfortable. First off, he's doing it on a PC, so if he makes a mistake, no harm, no foul. The PC, the Run My Virtual Machine, the PC version of it, the control panel, the programming panel, and everything is identical to the machine. So if he gets comfortable with it on a PC, it goes out to the machine. It's not like, well, the buttons all moved, everything's in a different place. It's identical. So he can train, he can practice right there, and he can readily try things and change things safely on a PC, see the results, and I can get him going and up to speed fairly quickly with just a beginning overall view of here's how this thing starts to work, and let him play with it. That's it. Hard Knocks is the best teacher that I've found because I could tell you everything, and how much of that is retained is a question mark. You learn it the hard way, you put that in your personal toolbox, you go, I am not going through that stuff again for an hour trying to figure it out. I know now.
Amen.
All right, let me check the question panel again and the chat. While I do that, let me just throw out one more question. All right. I also put in, since we were talking about Run My Virtual Machine and training, I put a link to the Siemens Technical Application Center for the complimentary for free machine tool training, operations and programming, the level 3, level 4 that Chris had mentioned, as well as dealer service training. So in the chat, it doesn't look like there are any other questions. And one question around skill development. How does the role of the CNC machinist evolve when using an automated setup like this? What new skills or training might be beneficial for machine operators in such an environment?
Well, when they are running this kind of an operation, this kind of a program that's so well automated, they can still follow along with the program. I have put in optional stops at the end of each event so he can intervene and toggle that anytime he wants to. Look in there, he can see the program as it's running. So he can catch a lot of things, learn a lot of things, and if he has questions, he can field them that I can address for him, or he can go up to the PC and practice and try it out and go, oh, that's what he's doing over there. So there's a lot of good mechanisms, and what I'm trying to do with this is to automate it so he doesn't have to be tied to the machine to get compliant parts. He is free to do other things. It may be on another Siemens control machine, a 3-axis machine, where he's doing something else and playing with the program. So it leaves him all kinds of options.
And then there's one last question, which I think is actually pretty good. So we should cover it. I know we're at time, but I think let's cover it regardless. Les mentioned that simulating the operation and run my virtual machine to avoid expensive mistakes. Could you provide more detail on how the digital twin process works and its importance in optimizing tool paths and validating complex machining strategies before actual production?
Well, there was a combination of things. One thing that I'd already mentioned quite a few ways is the tool holders, the projection, the tool projection from the tool holder to make sure that I'm not shanking out somewhere. But one of the other factors that I had is this part is quite large for the trunnion that we have. Diagonally is getting close to the ears of the cradle that it rides on, but I do need to get out there and face areas and mill areas. And if I used a certain tool, it would impede on the cradle of the trunnion. If I took certain paths, it would impede on that, or the fixture itself. I've got an adapter plate that goes up under the trunnion table. You're able to see all of those and then go, ooh, I didn't think of that. I got to change my approach this way or that way until you don't have any more collisions showing up and you go, okay, now I'm good to go. Where's the machine?
Yeah, and I would say, I think the one thing maybe to also make sure for full transparency, the digital twin itself, run my virtual machine, isn't going to automatically optimize your programs. It is up to you. What it is doing is it's giving you the sandbox where you can truly simulate what would be the real process on the floor, like Les is talking about, the exact fixturing, the exact work holding. But it's still going to be up to you as the programmer to figure out how you want to then adjust and optimize. This isn't like leveraging AI or doing anything like that. This is literally giving you as if you had your own private machine in your office, but you never have to get dirty. You never have to smell coolant. And you have this sandbox where if you drive a tool through the fixture, you can hit refresh and start again. But I tell you, I mean, Les is using it obviously for shop floor programming, great technique for that. But I use it all the time with a lot of CAM-based programs I do too. To have that ability of staying, being in my CAM, doing some tool path. I think I like it. Let me see how the real machine is going to behave, because that simulation in CAM might look pretty, but it's not always accurate. So then I'll post it in, run it in the digital twin. Oops. Yep. I didn't like that choice. Let me go fix it in CAM. So it can really become just part of that whole process chain.
Precisely.
Another question, can the digital twin account for coolant lines getting in the way of machining?
Not really. You could model the coolant lines, but they're going to be fixed. So if you model them, you could potentially have it detected as a potential collision, but it's never going to know if you move that lock line an inch over, right? So yeah, generally speaking, usually when you get to that kind of peripheral stuff, I would say if it's something a little bit more rigid, like I like to put my tool presetter, I like to have that shown in that space. If I have a laser presetter, I'll have that shown. Even though I might never use it, I want to see if I'm going to put a fixture on top of the thing. It's a great time. But a coolant line, no, unfortunately, I don't know if it would be worth modeling it up and making this rigid element. But maybe if you have one of those like programmable nozzle, that's something a little bit more fixed in space, right?
There's a comment in here. Very good information. Digital twin seems to be the future of machining. I would agree with that statement very much.
Well, thank you. Me too.
Yes. Very much so, particularly when you get deeper, like I said.
Yeah. And then another comment, I think learning the Siemens control opens up the door for operators to move on to higher end shops and machines. Chris?
Yes.
I think you can attest to that 100%.
I can. It's amazing. I've trained people remotely, and I've watched them like just kind of move their career up and up and up based on the technology that our systems are leveraged on. It's pretty cool to watch.
Yeah. All right, let me check the question panel one more time. I know we're just a couple minutes over in the chat.
While you're doing that, let me bring up our end contact information. So this way, if anybody would like to reach out, by all means, I'm certainly always available. Email is the best way to get a hold of me. I would assume, bless, you're probably the same.
Same.
Yeah.
Yeah. All right. So then with that, we'll bring this webinar to a close. Don't forget, if you want to read about some of the fantastic insights around the CNC Digital Twin, make sure to download the white paper that's up in the handout tab. You'll find that link in the upper right-hand corner of your screen. I would like to say thank you to Les and to Chris for the great discussion this afternoon. Thank you to everyone in the audience for joining us today, and especially for sticking around for a little longer than we had planned. As always, it's been an absolute pleasure. Take care, everyone.
Thank you very much, John.
Appreciate it.
Take care, Chris.
All right.
Bye-bye now.
Bye-bye.